Hello, my name is Darren Thomas, and I am the Director of Educational Research Technique. We are now in Chapter 4, Lesson 3, and we're looking at Lasso regression here. And so now we're going to do our model development, but I need to mention that, as you know, the main difference between Lasso regression and ridge regression is that with Lasso regression, some of the coefficients can be shrunken down to zero, which is basically a way of removing variables from the model, if not indirectly. So having said that, why don't we go ahead and move over to R. So here I am, I'm inside R, and our code is right here at the top. Lines 1, 2, and 3 are just for, if for whatever reason your environment was removed or whatever, you can just do that. We set our seed in line 3. Now I want to take a look at what's happening in line 6 in particular. All this information is exactly from chapter 3 when we did ridge regression. The primary difference here is the setting of the alpha. That is what's new in this particular situation. When you set the alpha to 1 in the GLM net function, it is telling it to do lasso regression. If you set it to 0, it's telling it to do ridge regression. So that's kind of what's happening there. Somewhere between above 0 but below 1 is off the elastic net. Elastic net is our next chapter in chapter 5, if you will. So you should already know what our predicted variables are and what our dependent variable is language score. This particular model is much simpler, only 4 or 5 variables. And I need to mention something that Lasso regression, ridge regression are very, very useful for data sets that have many variables, are also known as features. The reason we're using such small data sets is for the purpose of practice. It's less overwhelming to try to understand what's happening with a handful of variables. But these are very, very powerful techniques for big data type data sets with many features, with many variables, where you're trying to figure out what to keep and what to throw out. So please keep that in mind. So now, all this stuff inside the GLMNet function should be familiar if you looked at chapter 3, if you looked at unit 3. And so I'm not going to explain much. I'm just going to press Control Enter to run it. Whoops, excuse me. I'm going to press Control Enter to run it like so. And now we're going to take a look at the actual results. So you can see here that it only took 60 iterations to try to find a decent lambda for this particular situation. And so the deviance, you can see that it starts to improve pretty quickly here. And notice how the number of variables kind of changes sometimes, because remember, we're able to remove variables, if you will. Now let's take a look at the plot, if you don't mind. And so you can see here across the top, let me make this a little bit bigger. Across the top is the number of features that are in the model. Across the bottom is the log of the lambda, and then you can see how the coefficients decrease. You can see also that we have 3 variables in this. That is to be expected, because that's all the variables we had. Now let me zoom in for you a little bit so you can take a little bit of a closer look. So you can see variable 1 is way here at the top. It has a strong coefficient, if you will. And then variables 2 and 3 are down at the bottom. Notice how variable 3 eventually kind of disappears here. What's happening basically is that particular value is being set essentially to 0. And it looks like variable 2 didn't last that long either, but then variable 1 goes on for quite some time there. So this is kind of a visual of what's happening. Again, if you want to know what the variables are, you have to look, and I'm going to show you in a second. So let's just take a look at that. Okay, so as we look at the plot here, I mean not the plot, but the printout here, it seems like setting the lambda to about 0.02 is the best option. And so you can see right here in line 12, we've already set that up with our object called lasso.coef, if you will, and we set the lambda to 0.02 because that looks like it'll give us one of the better options, one of the better results for our deviance, percentage of deviance explained. So we do that, press Control Enter, and then we want to look at the results, Control Enter, and so you can see right here, variable 1 is IQ, looks like it hangs in there the whole time. Variable 2 is GS, and variable 3 is SES. So it looks like variable 2 is the one that really disappears first. It doesn't last very long because you can see clearly that this is essentially 0 right here. And SES, which stands for social economic status, it goes down to about 0.15. It hangs in there, barely. But so this is kind of the results of our model here, in that we have these three variables, and it looks like two of them, or basically one, is a fairly reasonable predictor of language score, their ability to test well on a particular test for language. And so the last plot we're going to look at is the percentage of deviance explained. And you can see here you kind of get the same results. So it looks like now variable 1 and variable 3 kind of hang in there. This is why you want to look at the different plots, because it's not so clear what's happening with variable 2 here, because it's kind of flatlined from the beginning. But if you look at the last plot, you can see clearly that variable 1, which is IQ, it hangs in there the whole time. And variable 3, it kind of goes up a little bit towards the end when you have the two variables in there. So that's kind of what's happening with the model development. So what we will do now is that in the next video, we will take the results that we got from this and we will run it in our final model and do the comparison between the training set and the test set. Now keep in mind that the scores that we get here, it all depends on comparison to other models. That's the main thing to remember. So in this video, we did a simple Lasso regression model. We figured out the lambda that we needed, as you can see right here in line 12 after looking at the plots. And so now we're ready to move on to the next step, which is the model testing. So I hope this video was useful for you, and I hope that you're starting to see how it's not that complicated. You do the same processes over and over again, and with practice it should become much more easier to accomplish this. So my name is Darren Thomas. I'm the Director of Educational Research Techniques. This is simpler, using practical use of machine learning algorithms in R. Thank you.